Hello everyone. Welcome back to my channel Learning Physics with Bhavya ma'am. If you have not seen my previous video, link is given in the description box. Please check. Students, I am doing the videos topic wise so that you can learn each topic in better way. So if you are having any doubt, confusion in the topics, or if there is any suggestion, please comment below. So your feedback makes me to improve better. Today we are going to learn the concept of force between multiple charges. We know that if there are two charges, like charges repel each other. If there are positive charges or if both are negative charges, according to Coulomb's law, we studied that they repel each other, right? So the two alike charges repel each other. So with the force F21 and F12, or if there are unlike charges plus Q1 minus Q2 at a distance R, then they attract each other, right? Q2 attracts in this direction, Q1 attracts Q2 in this direction, Q2 attracts Q1 in this direction. So this is a force on second particle due to first. So this is F12. So they attract each other, right? So this is according to Coulomb's law, which is applicable to two charges, right? Now, what is the magnitude of these two charges? They are equal, and it is given by the expression K Q1 Q2 by R squared and R cap. You can write R12 or R21. So we learned in last video till this much, right? And here you can notice that the forces, either they may be repulsive or it may be attractive. They act along the line joining the charges, right? It will act along the line joining two charges. So Coulomb's law, which tells about the magnitude and direction of the forces between two charges, right? Now, if you are having multiple charges in a system, then how to find the total forces? Let us consider this is Q1, and I'll take some charges arbitrarily, okay, Q3, Q4. Like this, if there are n number of charges in this space, we know that each charge exert force on other, right? So there exists a force of repulsion or attraction, right? So they interact with each other. Now let us consider Q1 exert force on Q2. So Q2 in turn exert force on Q1. Q3 exert force on Q1. Q1 also exert force on Q3. So Q1 exert force on Q4. Q4 in turn exert force on Q1. Like this, if there are n number of charges, they exert force on each other. Q1 exert force on Qn. Qn also exert force on Q1. So if I take any one charge here, so let us take Q1, then remaining charges exert force on Q1, right? Then how to find the total force on one of the charges? So let it be Q1. So for that we are taking the help of superposition principle. Superposition principle states that total force on given charge is the vector sum of the forces due to the remaining charges. Okay. So for that, first let us join these charges. So we need to do vector sum. For that, first let us join this. Okay. You can also consider the Cartesian coordinate system, and you can make you can write position vector for each charges. Okay, so I'll make it simple by joining this. You just imagine here there is a Cartesian coordinate system. Okay, so I'll just consider the charges. Okay, I'm not going to make this complicated. Okay, now I'll join these charges. First I'll join these charges. Okay, so here what is this distance? See, 2 to 1. This is charge Q1. So this distance is R to 1, right? So we are moving from 2 to 1. So therefore it will be R21. So this is R31 because this is Q3, Q1. The distance between Q3 and Q1, let it be R31. Similarly, I'll join this. So the distance is R41. Okay. Now, what is the direction of the force? So Q2, let it be all these charges are like charges. So Q2 exert repulsive force in this direction. Just extend this further. So this is force on first due to second. So you extend this line further. Okay. So, okay. Now, Q4 also exert force on Q1 in this direction. So force on 1 by 4. Similarly, 3 also exert force in this direction. Q3 exert force on Q1 in this direction. So force on 1 by 3. Right? Okay. Like this, if there are n number of charges, let it be 10 charges, then you have to find the force, find the direction of force due to 5th charge, 6th, 7th, 8th, 9th, 10th, like that. So there are so many direction of forces on the charge Q1, right? So now how to add? We need to add it vectorially. For that, you have to consider any two forces. Okay. So I'll consider only first two forces now. So you take these two forces, and last year we studied vector addition, right? By drawing parallelogram, right? So now we need to draw a parallelogram by taking these two are adjacent sides. Complete the parallelogram by taking this side is a parallel to this and join this so that these two opposite sides are parallel. Can you see one parallelogram here? Okay. So we completed the parallelogram by taking the parallel, this side is parallel to this and this side is parallel to this. Opposite sides are parallel. Now, so join this, see this is a diagonal. So this diagonal, join this. Okay, so this is a diagonal. Along the diagonal, resultant of these two forces are acting, right? Now I'll call this as some name. So let it be F dash. What is this? F dash is a force, sum of these two forces, right? Now I'm having only two. So one is F dash. So these two forces are reduced to F dash. And here I'm having one more, that is F14. Now I'll add these two forces. So once again, we need to construct a parallelogram, right? So these two are adjacent sides, and here I'll take one more line, okay, so parallel to this, I hope it is known to you, and I'll join these two like this, right? So these two are adjacent, say these two are opposite sides which are parallel, and these two opposite sides are parallel, right? Now, so by taking this as a origin, see here I have Q1, right? Q1 charge is here, right? So therefore, I need to take this point and join opposite end. So if I join this opposite end, what is this line called as? Diagonal. Along this diagonal, resultant force is acting. We have added F dash and F14, whose resultant is acting along the diagonal. This will be the force. Okay, this will be the direction of resultant force, right? So let it be F. Is it clear? What is F? F is a resultant of or sum of these two forces. Like this, we need to construct a parallelogram every time. If I am having one more force, so then this is one of the force, and here there is one more force. Let it be F15. Add that too. Okay, so you'll be having one more parallelogram and join the diagonal. Okay, diagonal. So that diagonal is called as resultant or sum of that two forces. Like this process which continues till the end force, right? So if I can see here, let us take F14 is a final force, right? Because I have taken only 3 more charges, right? Q2, Q3, Q4, these 3 exert force on Q1. So I am having how many forces total here? 3 forces. Okay, so first I have taken 1, 2 and F13 and added these. So F14 is a third force, right? So I have added that. So I have constructed only 2 parallelogram. If there are one more force, then 3 parallelogram you need to construct. So 4 forces means 3 parallelogram. Like that, if there are n number of charges, then n minus 1 parallelogram you need to construct, and every time you do like this, so that finally you will come to know what is the direction of the force on this charge due to remaining charges, right? Okay, so now what I'll do means, instead of doing like this, so it will be complicated you to find, right? So that's why what I'll do, I'll take only two charges. Q1 is a one charge on which two more charges exert a force, right? I'll take only Q2 and Q3, so that I'll make this picture easy, okay? Easy for us to understand, okay? So now I'll take only two more charges. One is Q1, I'll keep as it is, okay? So I'll take Q3 somewhere here, right? And let it be, sorry, Q2. Okay, Q2 or Q3, anything you can write Q2, and here I'll write Q3, right? Is this clear for you? Okay. Now first I'll join Q2 and Q1. So what is this distance? This is R21, right? The vector leading from 2 to 1 is R21. Similarly, join this vector leading from 3 to 1 is, after joining you extend this line further. So this is a force on first due to second. Similarly, you extend this line further. This is a force on first due to third. So I'll take only two forces, okay? So if I draw like this, it will be complicated for you. So if it is, see, if I draw like this, then it will be easy for you to understand the concept, right? So this much is enough. If this question is asked for 3 marks in board paper, you write only this diagram, okay? This is just for understanding the concept. You write this diagram. This is enough. Now we are having, see here, the charge Q1 experiences two forces. Then what is the direction of the final force? What is the direction of the total force? So we are using superposition principle here. According to that principle, total force is vector sum of forces due to remaining charges. So vector sum means there are two, actually. One is triangle law of vector addition, another one is parallelogram law of vector addition. I'll use parallelogram law of vector addition. For that, already we are having two sides, adjacent sides are here. There are two more sides required, right, to construct a parallelogram. Two more sides are required. So how to draw? You know already. I'll write once again. See here, you have to draw one line parallel to this, like this. Okay, draw one line parallel to this. Similarly, okay, I'll write using this. Draw one line like this. Similarly, join this to this head. Okay, alright. So this, like this. Okay, arrow is not required, just simply join this. Now, so here you can see there are two diagonals. One is this diagonal, another one is this diagonal. There are two diagonals. Diagonal means, so if you join opposite corners, that is called as diagonal. Parallelogram is having two diagonals. But which diagonal you need to consider here? So we have to take those diagonal which passing through this point, right? So here at this point we have placed Q1, right? We need to find the total force on Q1. So therefore we need to take this diagonal. So join this opposite ends, right? So if you join these two ends, then this is a direction of the force on Q1 due to remaining charges, right? So we know that the total force is, or resultant force is acting along the diagonal taken from same point, right? Yes, students, is this clear? Any doubt here? Please go through it again. Okay, so this is the total force F1. Now we used Coulomb's law as well as superposition principle to identify the direction of total force on charge Q1, right? Now let us write the magnitude. So how to write the magnitude of force? Yes, let us use Coulomb's law. As I mentioned, you have to take only two charges at a time. Q1 is a charge on which other charges exert a force. That's why you have to take Q1 and any other charges at a time. Take only two charges. Now, force on Q1 due to Q2 is, how to write? Force on 1 due to 2, F12 is constant K. You can also write 1 upon 4 pi epsilon naught, but I am not writing. I'll just write constant K, Q1, Q2 divided by, so which, say here you have to write R21, R21 square, R21 cap. Call it as equation 1. So I'll write the second one, force on Q2, sorry, force on Q1 due to second charge. That is, see here, this is one charge, this is second charge. So it is Q3 is F13. So constant K, Q1, Q2, R31 square, R31 cap. I'll call it as equation 2. So just to understand this concept, while drawing the picture, I've taken only 2 charges, but you know that it consists of number of charges, n number of charges. So therefore, let us write like this. So F1n, n is anything, any number of charges. So K, Q1, this is Q3, okay. So Q1, Qn, Rn1 square, Rn1 cap, okay, like this. Now, I'll rub this. Okay, I hope it is clear. Now, what is the total force? Total force F1 is vector sum of forces due to remaining charges. That is F12 plus F13 plus F14 plus so on plus F1n. Right? So, here, what is that? Constant K, Q1, Q2 by R21 square, R21 cap, plus constant K, Qn, Rn1 square, Rn1 cap. Right? Okay. Now, so which is constant here in this expression? You can see that K is constant, and which one is common in all the terms? Q1 is common, right? So you can see that here first term Q2 R21, in second term Q3 R3, so like that Q4 R4, and like that Qn Rn. That means here this is a variable, second charge is a variable, right? So therefore, you can write it varies from 2 to n. So therefore, and we are adding all these. So let us write summation. Summation. So I is a variable, varies from 2 to n. Qi divided by Ri1 square, Ri1 cap. Right? Is this clear, student? So what is the final expression? Force on the given charge is constant 1 by 4 pi epsilon naught. Q1 is a charge on which the remaining forces are acting, right? So Q1 summation I varies from 2 to n. Qi Ri1 square Ri1 cap. Okay. Like this, we used superposition principle to find the total force on given charge due to remaining charges. Right? So, if you like my videos, please